Jai Hind all. This is Assistant Professor Gagandeep Singh from Ajay Kumar Garg Engineering College. This is a lecture series on satellite communication, and we are discussing the complex topics. This complex topic is related to the last unit where we have completed all the architecture, all the different aspects of the satellites. We have discussed the satellite workings. We have discussed everything about the satellites. Now we are trying to fabricate or architect with the architecture of the small satellites. So we know that satellite is any artificial body. It can be natural, but we are here taking a artificial body which is placed in the orbit in any planet, around any planet. Here we are discussing the Earth satellite. So artificial body that is revolving around the Earth is the uh, satellite. Generally, it is used for collecting any information and transmitting that information to the Earth station. Till now, there are so many satellites that has been launched by India. Uh, so there are also launched by some universities and thus by some students also. In GSAT 16, that was 24th communication satellite that was launched in uh, 2014. It has 48 communication transponders in a single satellite. So we know that we have different type of satellites be depending upon the weight and the weight. We classify as them large satellites. Large satellites are the satellites which has a weight more than 1,000 kilograms. As the weight increase, the transponder size increases. This increases the cost of the satellite. For example, in the previous slide, we have discussed that GSAT has 48 transponders. These 48 transponder will have a higher weight. To reduce the weight, one is to reduce the transponders, but with the reduction of the transponder, the bandwidth, the number of channels, all those will be decreasing. So there are other satellites like mini satellite which weighs hundreds of kgs, and the cost is approximately $10 million. Then there is again micro satellites which is which has weight of 10 kgs or 10 kgs to 1000 kgs. As the size is decreasing, the cost of satellite is also decreasing. Generally, the microsatellites and the other satellites, these are satellites which do not have higher number of transponders. They are generally used for collecting data and transmitting that data to the Earth station. Further reducing the satellite's weight, the weight, if it is less than 10 kg, or it can be more than 0.1 kg, so then it is called the picosatellites and the nanosatellites. In this category, there are two satellites. One is picosatellite and the nanosatellites. These are the picosatellites and these are the nanosatellites. You can see the shape of the size of the nanosatellite, which is lesser than the hand. Then last are the femtosatellites. These are generally uh, communicating direct, to some satellite for the transmission of the signal. These are communicating to the satellite, and satellite is sending the signals. These are generally, you can see the some IoT devices like satellites which senses the environment and then transmits the signal to the earth station. With this you can see this is only like a chip, and the size weight of the chip is approximately 0.1 kg. So as the size of the uh, satellite is decreasing, obviously the cost will be decreasing. However, there will be some limitations like the particular area only can be focused for the application. We cannot use it for the wide applications. So as we are going higher in lesser in the weight, then the more uh, complex satellite will have to work, and the lifetime will be decreasing. For example, these femto satellites are used for few hours only for collecting the data and transmitting it to the other satellites. However, as we go with the the size, larger size, the cost of the satellite will increase. We know that in the satellite communication, the cost is much more prominent factor for launching, because it is very high cost. So generally, we are interested with the small satellites where the cost is not very much high, but also the launching the satellite is not very much costlier, because in a one satellite we can launch these satellites as a piggyback satellites. Generally, these satellites, picosatellites and microsatellites, are also known as the CubeSats. These are the one unit height, 1 unit length, and 1 unit width. So this is 1U satellites. Similarly, this microsatellite can be 1 unit height, 1 unit length, and 1 unit uh, uh, width. But here this is the one unit, and that this is the second unit and the 3 unit. So this is a CubeSat of the 3 units. So such a way the different micro and the pico satellites are designed. So we are focusing on the pico satellites because first of all it is a satellite which can be easily fabricated. The small size is small, and we can create a particular application using these satellites. So we can create a satellite in our house or in our college uh, for for a particular application. For example, one satellite that can be seen or can be fabricated is a phone set. Phone set was a satellite which was started in 2010. This was a nano satellite. Uh, Actually, it was a phone which is used as a payload in the satellite system. So inside the that satellite, we place a phone as the payload. Now, in a payload, we need some sensors. As we have discussed that in the smaller satellites, there will be no transponder. There will be generally sensors. So when there will be a sensor, now if we see our phone, there are a number of sensors. There is a proximity sensor, there is a temperature sensor inside the phone, there are touch sensors, there are heat sensors, there are cameras. So all these make a smartphone a collection of a number of uh, different uh, IoT sensors. So if we want to use this phone as a sensor, we can use it. So this concept was used to create a phone set in 2010. Now this with this start of the phone set, there was a series that was launched by the NASA. So phone set is we will discuss these things, why we use smartphone, what is new in it, how what the phone set can do, and what are the various challenges that will be do. So first thing, we as I have gives a glimpse, is that it has one or more cameras which can be used as a payload. Also there is a memory, large memory can be incorporated in a small faster CPU with more memory that is already available in a phone. Also, there are a number of rotation and the acceleration sensors. For example, we have a compass over there. So then there is a GPS receiver that is also there. Last one, also there are some radios for the communication. Even though we have to modify those radios, but already some communication radios are available in this phone set. So this phone set will reduce the cost, overall cost, because a phone that after modification will use approximately 3000 USDs. So the size will be reduced, the cost will also reduce, also the complexity will be not very much high because we are using only a phone. So there was 5 satellites that were launched. 5 phone sets were launched. These are just generally 1 to 2.4 that phone can be transmitted. The 2.4 was the phone that took some pictures from the space and transmitted it to the earth. So this was the progress. You can say this is the one of the applications that has been used by the phone set, that it using the phone's camera camera, some pictures of the space was taken and those were transmitted toward the earth station. The one problem you can see that it have a shorter lifetime, 2 to 3 days, because one thing we know that the batteries of the this phone is very not very much high, are highly consuming power consuming batteries. So the battery size is one problem that makes the life of the satellite shorter. Also, the sensors and the other things have to withstand with the wear tear of the space and the very low temperature of the space. All these harsh conditions phone cannot withstand for the longer time. For these reasons, that the lifetime is the shorter phone. This is the first phone set that has been launched. This is the antenna of the satellite, and this is 1U and the 1U satellite. So this is approximately a pico satellite just before launch into the space. Here inside this one, the phone is placed. This phone is placed inside this whole chamber, which is thermally insulating the phone. This is the camera which is the taking the pictures of the phone from the phone. So this is the phone set 2. The size was a little larger, but less than 10 kgs. So it was taking the phone inside this one, and these are a number of batteries that has been applied. After this one, there was insulation over it. This one, this satellite, and there were also the satellites uh, antennas that are like this one. So all these things were later on encapsulated into the protective layer and then transmitted. This is in a lab. Then there is phone set 2.4. 2.4 satellite is approximately similar to the one. Here we can see that this one is the camera that is facing toward the facing out of the box, and this is again you can see that this is 1U satellite. So the size is approximately less than 1 kg. So these are also this is also a pico satellite, and there are some antennas that are coming out for this one communication as well as for the beacon signals. And all the covers over here will have some these solar panels. So for the battery consumption, for the uh, power consumption of the satellite, some solar panels are over the phone set cover. So then there was 2.5 satellite. After 2.4 satellite, there was 2.5 satellite, because the 2.4, 2.5 are these are the working, and they were showing some responses. So this is just to check the feasibility of the control system that is placed inside the satellite. So besides that satellite, there is some control system that has to also be incorporated. Then there is a capacity of to check the capacity of the smartphone to support space-based communication was discussed from because we know that in the phone generally works on 5G, 6G, 2.4, 2G, 3G, 4G, 5G, or 6G. All these need some infrastructure. So when we need infrastructure, for example, BTS, we have some communication range between the satellite and the BTS. But when we go out of this one, then there is no communication from the phone. So there is some modifications were done for the whole higher communication ranges. So to check the capabilities of smartphone for the communication in the satellite, this was 2.5 was launched. Its weight was just 1.6 kg, and it was a LEO satellites. All these were LEO satellites because of the low power of the resolution power of the camera, as well as the lower communication range. So it is launched at the 350 kilometers from the above the Earth. The architecture of this one, you can see that one of satellite, one of smartphone. It is using smartphone for all the communication. The satellite that was using at that time was Nexus 1 phone. Now this needs some beacon signal. Beacon signal was sent to the stand set, and then there was a watchdog timer for the all the regulations in the satellite. This watchdog timer and smartphone and beacon signal are supported with the lithium ion batteries. Approximately 3.7 volt was transmitted. The data that was transmitted in between was using the UART UART buses. If we elaborate this architecture, the architecture was used in 2.5 phone set was that solar panel was used, which was supporting the batteries. Again, if phone was used, this phone was Nexus S. At that time, Nexus S was one of the durable phone. Then a watchdog timer, as we have used, and uh, a beacon signal to the Stansted satellite was there. These all things were already there in the previous phone sets. So these were the tested satellite. They are tested satellite components that was used. Then there was Atmega controller coils and the motors were used, and there was some current sensors and the temperature sensors that were also used to check the health of the satellite. Then there was also a router, small router was used. All these three were used to check to make the more uh, satellite more stable in the space, as well uh, to check the health of the phone. Last one, there was a radio was also used. Micro hard was used for communication. So with this one, we can see that to qualify a new technologies component for the space flight, phone set was a kind of milestone. A new kind of payload to track the orbital debris and the near Earth objects. As we have seen that some satellite pictures were sent by the phone set. So these pictures now were can track and detect the debris in the orbit of the phone set. Also, it can conduct a low-cost Earth observation, Earth observation with the smaller compromise uh, on the resolution of the pictures. Even though nowadays the phone has higher resolution, but still the special resolution that is achieved by the satellite, special purpose satellites, it cannot be achieved by this one. So we can conduct a low cost Earth observation using this one. Using distributed sensors to measure the space weather phenomena is important application using this phone set. So, few applications that can be used where satellite phone set can be used. One is the using its camera for taking the images of the space as well as the Earth station. When it is taking the Earth satellite, Earth's station or Earth's images, the Earth surface imaging of few megapixel camera can be taken. So this can be add on to the GPS or the any navigation system for the Earth imaging. Then if it is taking the image of the uh, space, then debris and the near Earth or objects can be identified as its height is low. So we can locate the near Earth orbits. Then locating aircraft's position by imaging is also important application, because the satellites are uh, of low resolution, as well as these are the LEO satellites. So the satellite, the spacecrafts, uh, spacecrafts position and well the images can be taken by using these satellites. Now, first thing, the major challenge is that lifetime of the phone set. We are spending a small, quite a amount of satellite to launch, but satellite's lifetime is not too high. As we have discussed the various reasons for the for the lesser lifetime. Second thing, even though we have now a higher resolution cameras, but still the quality of those cameras are not that much high to the particular specific camera area. So the comparison between the phone set and the normal camera can be taken as a quality. Last one is actual application is depends upon the phone as well as the user. So last one is the working of the payloads, working with the payload and the radios is also to be done, because we have seen that the satellite cannot be used, cannot communicate directly for the communication of the satellite to the Earth station. We need some changes in the satellite, because the height is 350 kilometers. At the 350 kilometers, the radius of the phone cannot work directly. So we need to incorporate some of the beacon signals, for example, with the stand set for the communication, as well as we have to include some of the other radios for the communication between between the small satellite and the Earth station. So thank you. This is, I think, this will give a glimpses of the satellite fabrication, how satellite can be made, and also this gives a glimpses of one of the uh, uh, key satellite, which is the phone satellite. There are a number of other ways in which satellites are fabricated. Generally, the structure of the satellite is made 3D printers for a lightweight satellite fabrications, and these structures where lightweight satellite are there, a phone can be placed. There are other things that can also be done, like for example, the phones that can be used, those can be deconstructed into a smaller size. For example, the screen is not required, so we can remove the screen of the phone for the usage in the satellite. So we can separate out some of the sensors. However, this will increase the cost because we have to separate the things. So this will be increasing some of the fabrication costs. Also, some complexity will be incorporated in this one. So this was the phone set, which was architecture of phone set, where phone is placed inside the uh, cubical structure to create a phone set.